Let's talk about MANOVA and ANOVA. We will read this chapter in brief. What is the learning objectives? Upon completing this chapter, you should be able to do following. Explain the difference between the univariates and null hypothesis of ANOVA and the multivariates null hypothesis of ANOVA. Discuss the advantage of multivariate approaches, significance testing compared to the more traditional univariate approaches. State the assumptions for the use of MANOVA. Discuss the different type of tests statistical are available for significant testing in MANOVA. Describe the purpose of post hypothesis ANOVA and MANOVA. Interpret intention result when more than one independent variable is used in MANOVA. Describe the purpose of multivariate analysis of covariance MANOVA. We'll read the chapter review. Multivariate analysis of variance MANOVA is an extension of analysis of variance ANOVA to accommodate more than one dependent variable. It is a dependence technique that measures the difference for two or more metric dependent variable based on set of categorical non-metric variable acting as independent variable. ANOVA as MANOVA can be stated in the following journal for this. Analysis of variance. Y1 is the metric is equal to x1 plus x2 plus x3 and number of xn. We call it non-metric. Multivariate analysis of variance y1, y2 and number of yn is equal to x1, x2 and xn. Matrix, here is the non-metric. Like ANOVA, MANOVA is concerned with difference between group or experimental treatments. ANOVA is termed a univariate procedure because we use it to assess group differences on a single matrix dependent variable. MANOVA is termed a multivariate procedure because we use it to assess group differences across multiple matrix dependent variables simultaneously in MANOVA. Each treatment group is observed on two or more dependent variables. The concept of multivariate analysis of variance was introduced more than 17 years ago by Wilkes. However, it was not until the development of appropriate tests, statistical with tables, distribution, and the more recent whispered availability of computer program to compute this statistic that MANOVA become a practical tool for research. Both ANOVA and MANOVA are particularly useful when used in conjunction with experimental design, that is research design, in which the researcher directly control or manipulate one or more dependent variable to determine the effect of independent variable. ANOVA and MANOVA provide the tool necessary to judge the observed effect, that is, whether an observed difference is due to a treatment effect or to random sampling variability. However, MANOVA has a role in non-experimental design, that is survey research, where group of interest, for example gender, purchases, non-purchaser as defined, and then the difference of any number of matrix variables, that is attitude, satisfaction, purchases, rate, are assessed for statistical significance. Key terms. Before starting this chapter review, the key terms to develop an understanding the concept and terminology to used. Throughout the chapter, the key term appear in a bold case. Other points are emphasized in this chapter and key term across the reference and italicized. Let's talk about the alpha A. What is this? This is a significant level association with the statistical testing of the differences between two or more groups. Typically small value such as 0.5 or 0.0 are specified to minimize to possibility of making a type 1 error. Analysis of variance ANOVA, statistical technique used to determine whether the sample from two or more groups come from population with equal means, that is, do the group means differentiate significantly. Analysis of variance examine one dependent measure where multivariate analysis of variance compare group differences on two or more dependent variable. A prior test C-plant comparison beta B C type second error. Let's talk about the blocking factor. What is this? This is a characteristic of respondent in the ANOVA and MANOVA that is used to reduce within the group vari- variability by becoming an additional factor in the analysis. Most often used as a control variable, that is the characteristic not included in the analysis but one for which differences are expected or proposed. By including the blocking factor in the analysis, additional groups are formed that are more homogeneous and increase the chance of showing the significance differences. As an example, assume that customers were asked about their buying intention for a product. An independent measure used was age. Prior experience shows that substantial variation in buying intention for the product of this type of was also due to gender. Then gender could be added as a further factor so that each age category was split into male and female group with greater within group homogeneity. Let's talk about Bonofroni inequality. Approaches for adjusting the select alpha level to control for the overall type 1 error rate when performing a series of separate tests. The procedure involved calculating a new critical value by dividing the proposed alpha rate by the number of statistical tests to be performed. For example, if a zero point zero 0.05 significance level is desired for a series of 5 separate tests, then the rate of 0.01 and 0.05 divided by 5 is used to each separate test. Box M test. Let's talk about statistical test for the equality of the variance, covariance matrix or the independence variables across the groups. It is spatially sensitive to the presence of normal variable use of a covariate significance level, that is 0, 1 or less, is suggested as an adjustment for the sensitivity of the statistic. Contrast. Procedure for investigating specified group differences or interest in conjunction with ANOVA and MANOVA. For example, comparing group means differences for a specified pair of group. Covariate analysis, use of regression like procedure to remove extraneous nuisance variation, the dependent variable due to one or more control metric dependent. Variable covariate. The covariate are assumed to be linearly related to the dependent variable. After adjusting for the influence of covariance, a standard ANOVA or MANOVA is carried out. These adjustment process known as ANOVA and MANOVA usually allow for more sensitive test of treatment effects. Critical value. Value of a test statistic t-test, f-test that denotes a specified significance level. For example, 1.96 denote a zero point 0.5 significance level for the t-test with large sample size. Discriminant function. Dimension of the difference or discrimination between the group in the ANOVA-MANOVA analysis. The discriminant function is a variate of the dependent variable. Disordinal interaction. For the interaction effect among the independent variable that invalidate interpretation of the main effect of the treatments. A disordinal interactions is exhibit graphically by plotting the means for each group and having the lines intersect or cross. In this type of the interaction, the mean differences not only vary given the unique combinations of independent variable level but the relatively ordering of the group changing as well. Effect size. Standardized measure of group differences used in the casuation of statistical power calculation as the differences in a group means divided by the standard deviation. It is then comparable across research studies as the generalized measure of effect, that is the differences in a group means. Experimental design. Research plan in which the research directly manipulate or control one and more dependent variable, see the treatment of factor and assess their effect on the dependent science. For example, respondent are shows separately advertisement that vary systematically on characteristics such as different approach, emotion versus rational. On type of presentation, color versus black and white, and are then a kid their attitude, evaluation, or feeling towards the difference advertisement. Experiment experiment wide error rate. The combined overall error rate, the result from performing the multiple test or F test that are related, for example, test among a series of correlation variable, pair of a series of t test among the pair of categories in the multi-dichotomous variable factor. Non-metric dependence variable, also referred to as the treatment or experimental variable. Factoring design more than factor treatment. Factorial design examine the effect and several factors simultaneously by performing group based on all possible combination of level value and various treatment variables. Journal liner model, we call it GLM, generalized estimation procedure based on three components. Number one, a variate formed by the linear combination of independent variable. Second, a probability distribution specified research based on the characteristic of the dependent variable. And third, a link function that denote the connection between the variate and the probability distribution. Hotelli GST square test assess that statistical significance of the difference of on the mean of two or more variable between two groups. It is a special case of MANOVA and with two groups or level of treatment variable. Independence. Critical assumption of ANOVA and MANOVA that require that the dependent measurement for each respondent be totally uncorrelated with the responses from other respondent in the sample. A lack of independency severality affect the statistical validity of analysis and unless correlative action is taken. Interaction effect. In factorial design, the joint effect of two treatment variables in addition to the individual main effect. It means that the difference between the group on the one treatment variable depending on the level of second treatment variable. For example, assume that respondents were classified by income, three level and gender, male versus female. A significant interaction would be found when the differences between male and female on the independent variable varied substantially across to the three income level. Link function, a primarily component of the journal liner model, the specify the transformation between the variate of independent variable and the specified probability distribution in MANOVA are regression. The identify link is used with a normal distribution corresponding to our statistical assumption or normality. Let's talk about main effect. In factor design, in individual effect or each treatment variable on the dependent variable. Multivariates normal distribution. Generalization of the univariate normal distribution to case of p variable. A multivariate normal distribution of sample group is a basic assumption required for the validity of the significance test or in MANOVA. Null hypothesis. Hypothesis with sample that come from population with equal means, that is the group means are equal for either a dependent variable univariate test or set of the dependent variable multivariate test. The null hypothesis can be accepted or rejected depending on the result of a test of the statistical significance. Ordinal interaction, acceptable type of interaction effect in which the magnitude of differences between group vary but the group relatively position remain constant. It is graphically represented by plotting means value and observing non-parallel lines that do not intersect. Orthogonal statistical independence and absence of association. Orthogonal explain the unique variance with no variance explanation shared between them. Ortho, on the contrast, are planned comparison that are statistical independent and represent unique comparison of group means. Pillai criterion test for multivariate differences similar to Wilks lambda. Plant comparison. A prior test, the test a specify comparison on a group means differences. These tests are performed in conjunction with the test for main interaction effect by using the contrast. Statistical post hoc test. Statistical test of means difference performed after the statistical test. The main effect have been performed. Most often post hoc tests do not use a single contrast but instead test for differences among all possible combination of group. Even though they provide abundant diagnostic information, they do not inflate the orally type 1 error rate by performing multiple statistical tests, and those must be strict confident level power. Probabilities of identifying a treatment effect when it actually exists in the sample. Power is defined as 1 beta. C beta power is determined as the function of the statistical significance level alpha set by the researcher for the type 1 error, the sample size used in the analyze and effect size being examined. Repeated measures. Use of V or more responses from a single individual in ANOVA or MANOVA analysis. The purpose of repeated measurement design is to control for individual level differences that may affect the within the group variance. Repeated measurement represent a lack of independence that must be accounted for a special manner in the analysis. Replication. Replicated administration of an experiment with the intention of validating the result in another sample of respondents. Roe greatest characteristics route. Statistical for testing the null hypothesis in MANOVA. It tests the first discriminant function of the independent variable for its ability to discriminate group differences. Significant level C alpha. Step down analysis test for the incremental discriminantly power of the dependent variable after the effect of other dependent variable have been taken into account, similar to stepwise regression or discriminant analysis. This procedure, which relies on a specified order or entity, determine how much an additional dependent variable add to the explanation on the difference between the group in the MANOVA analysis. T, T statistic T statistic that assess the statistic significance between two group or a single dependent variable. See T test. T test T test to assess the statistical significance of the differences between two sample means for a single dependent variable. The T test is a special case of ANOVA for the two group of the level or the treatment variable. Treatment independent variable factor that are a researcher manipulate to see the effect if any of the independent variable. The treatment variable can be several level. For example, different intensities of advertising appeal might be manipulated to see the effect of consumer believability. Type 1 error probability or rejection the null hypothesis when it should be accepted that it is concluding that two means are significantly different when in fact they are the same. Small value of alpha, that is the 0.5 or 0.01, also denote as a alpha lead to rejection of the null hypothesis and accept an alternative hypothesis that population means are not equal. Let's talk about the type second error probability or failing to reject the null hypothesis when it should be rejected, that is concluded that two means are not significantly different when in fact they are different, also known as the beta error. Use statistics. See Wilkes Lambda variate linear combination of variables in MANOVA. The dependent variable form into the variable in the discriminant functions vector set of the real number, for example x1 n xn that can be written in the column or rows. Column vectors are considered conventional and rows vector are considered transported. Column vector and row vectors as shows as follows. X is equal to x1 x2 and xn, and x3 is equal to x1 x2 and x3. We call it, this is the column horizontal and row is the vertical. Wills Lambada, one of the four principles statistical for testing the null hypothesis in MANOVA, also referred to as the maximum likelihood creation of U statistic. MANOVA extending extending univariate method for assessing group differences. Many times, multivariate technique are extension of univariate technique, as in the case of multivariate regression, which extended simple regression with only one dependent variable to a multivariate analysis where two or more dependent variable could be used. A similar situation is found in the analyzing group differences. This procedure can classify as univariate not because of the number of independent variable known as the treatment or factor, but instead of because of the number of dependent variable. In multiple regression, the term univariate and multivariate refer to the number of independent variable, but for ANOVA and MANOVA, the terminology apply to the use of the single or multiple dependent variable. Both of these techniques have long been associated with the analysis of experimental design. The multivariate technique for analyzing group differences are the t-test, whose group and the analyzing of variance. ANOVA for two and more groups. The multivariates equivalent procedure are the hotline T2 and multivariates analysis of variance respectively. The relationship between the univariates and multivariance procedure are as the following. Here is the number of dependent variable, number of group in the independent variable, one univariates and two and more, we call it multivariates. Two groups specialized case we use t-test and hotlines T2. Two and more groups analyzing of variable ANOVA. So in the two groups, one univariate we apply t-test, and more than two groups we apply ANOVA, and multivariate analysis cases we use researcher use MANOVA. T-test, the hotline T2 are portrayed as a specialized case in that they are limited to assign only two categories for an independent variable. Both ANOVA and MANOVA can also handle the two group situation as well as address analysis where the independent variable have more than two group. A review of both the t-test and MANOVA are available in the basic state appendix on the website. We'll discuss multivariate procedure for assessing the group differences. A statistical interface procedure, both the univariate technique t-test and MANOVA and their multiple extension hotline t-test and MANOVA are used to assess the statistical significance cases of differences between group. In the t-test and ANOVA, the null hypothesis, the equality of the single dependent variable means across the group. In the multivariate technique, the null hypothesis tested in the equality of the vector of means one multiple dependent variables across the group. The distinction between the hypothesis tested in ANOVA and MANOVA is illustrated in the figure 1. In the univariate cases, a single dependence measure is tested for equality across the group. In the multivariate case, a variate is tested for equality. The concept of a variate in the instrumental in a discussion of many multivariate techniques. In MANOVA, the researcher actually has two variates one for the dependent variable and another for the independent variable. The dependent variable is more interest because the metric dependent measurement can be combined in a linear combination we have already seen in multiple regression and discriminant analysis. Multivariates aspect of MANOVA in that the variate optimally combine in the multiple dependent measurement into a single value that maximize the difference across the groups. ANOVA H is equal to me1 is equal to me2 and me has. Null hypothesis all group means are equal, that is come from same population MANOVA. Null hypothesis all group that vector are equal to the come from the same population. Let's talk about the two group case hotline T2. Assume that researchers were interested in both the appeal and purchases intent generated by two advertising messages. If only univariate analysis were used, the researcher would perform separate tests on the rating of both the appeal of the message and the purchases intent generated by the message. Yet the two measurements are intercorrelated. Thus, what is really desired is a test of the differences between the messages on both variable collectively. Here is where hotline T2, a specialized form of MANOVA and direct extension of the univariate t-test, can be used. Controlling for the type 1 error rate. Hotlines T2 provide statistical test of the variate confirmed from the dependent variable, which procedure the greatest in group of differences. It is the address the problem of